Hello. In this video, I will be giving an overview of the code of the Webserver utility used for seeing the video output of the CSI and the Z camera along with several other features. So in this video, I'll be going through all of the modules and how all of them come together for the Webserver. So this Webserver is actually quite extensible. It supports the Z camera, but if the Z camera is not connected, it falls back to only using the CSI camera. And that is handled by checking if the PyZ library can be loaded. In case the library cannot be loaded, that means that the Z camera is not available. So in that case, we will only use the CSI camera. So the main class where we can start looking through the code is the server class. The server class is used for starting the CherryPy web server and initializing the paths to all the directories. So in the vendor path, we have all the we have all the Bootstrap source code. In CSS, we have all the style sheets. Web fonts are used for fonts, and WS is used for the WebSocket handler. The WebSocket is used for live data streaming from the server to the web page. And it will be clear in this video where that is used. So the first thing which I like to show over here is the log files. So we create two log files, access.log and error.log. These log files are used for storing debug information of when the server is launched. We have the CherryPy config updated over here, and over here we update the configuration with the host, the port number, and also the files, the log files, and we also initialize the CSI streamer. So the CSI streamer is a separate thread which is used for streaming data from the camera. So if it's a CSI camera or if it's even a webcam, both of them work the same way because they both use the v4l2 driver. So in this case, the CSI streamer is actually running a separate thread, and that thread is initialized over here. After this, I'll be going through how the CSI streamer is actually passing data onto the web server. In case the Z camera is detected, then in that case, we will initialize the Z streamer, and the Z streamer is a thread which is actually getting frames from a Z process. So Z process, which you can see over here in the code base, that is used for actually initializing the Z camera and also getting frames from the Z camera. The reason why the Z camera runs in a separate process is because this gives more computational power available to the web server, because in Python, in case you need to run things on a separate core, you need to run them in a separate process. So that is the reason why the Z camera frames need to be processed separately, so they can use a different core from the web server. And the Z streamer is basically just a thread which interacts with the Z process and gets frames from the Z process. So that is how the Z streamer and Z process interact. And then over here, we start initializing all the modules of this project. So each module is called a handler, and we have handlers for each functionality. For example, the recording utility gets a handler, recording handler. The barcode detection gets a handler. Detection handler is used for the object detection, and in case these are not available, we have another handler called the disabled handler, and that is just used for printing an error message that this functionality is not enabled presently. We also have a files handler which is used for listing the files which are available, and a documentation handler which lists all the documentation of the project, basically just a user guide of the project. Test handler is used for debug purposes, but it's not currently required. So once we have mounted all the handlers, you can see here how the mounting is done. In the first, you need to initialize the object which is going to handle requests to this URL. So for example, the barcode handler will handle all the requests which come to /barcode, and so similarly, the recording handler is actually the index page. As you can see, it's just a slash over there. So that is the syntax. We have a handler, and we specify the URL which that handler should take care of. And we also need to have a CP configuration dict, and that just lists all the properties which are required of that handler. Then we also have a function for getting the IP address. So because this project is meant to be extensible and you can use the web server on multiple network interfaces. So the so get IP address, if you give it the name of the interface such as WLAN 0 or Ethernet 0, it will find the IP address and then you can use that for actually launching the web server. In the main function we have all the command line arguments. This is explained in the documentation what each of these command line arguments are used for. Okay, so now that we have gone through a quick overview of the web server's code, we can now look at the handlers. So I'd like to start with recording handler. So the way CherryPy works is, this code is quite long. So the way CherryPy works is that each endpoint which is exposed by the server will have this annotation. So if you scroll down, you might see some functions have an annotation at cherrypy.expose, and these are basically endpoints which the server can use for serving data. So for example, we have a stream endpoint which is used for showing the video stream, and shutdown is used for shutting down the server, for example. So we have multiple endpoints in this project. I won't be going through all of them, but from the code I think it should be clear what each of these do. So the basic thing which is going on over here is that the recording handler is taking the CSI streamer and the Z streamer. It's getting frames from both of these streamers, and then it's displaying these frames on the web server's UI, as you can see on the index page, and it also gives options for recording that to a file. So we can take a look at how the recording happens. So the recording is handled by CSI streamer.py. So if you go to CSI streamer.py, this is the thread which is actually reading frames from the CSI or the webcam. Yeah, so CSI streamer is reading frames from the webcam, and that is done over here, I think. CSI recorder. Right, so over here we initialize the device which we're using. So we have to give it the v for L2 device number, like /dev/video0 or /dev/video1. So we have to mention either 0 or 1 over here. We set the resolution, and after that over here we read frames from the camera in an infinite loop or until it's received a shutdown signal. And once we've read a frame, we then publish it on the CherryPy's CSI frame channel. So CherryPy has a publish and subscribe model in which you can publish data and then have other subscribers process that data. So in this case, we are publishing each frame on a channel called CSI frame, and now anyone who has subscribed to this channel CSI frame can access the last frame which has been published. So that is also, you can see how that works in CSI recorder.py. Sorry, it's not in CSI recorder, but since we've reached this file, the CSI recorder is used for recording data to a file. So we've basically split up the code from the streaming. So the actual video streaming is happening in a different place, but the recording is happening in a separate class, as you can see over here. And the reason for that was so that we could record multiple streams of data at the same time. For example, you might want to have some data recorded from the detection process as well as the barcode detection at the same time. So having a CSI recorder class actually allowed us to have that flexibility. Right, so CSI streamer basically just runs in the background. It runs in its own thread, and it will just keep publishing frames on the CSI frame channel, and then any of the handlers which want to can just subscribe to that and get a frame. So an example is probably here in CSI recorder. So here, for example, we have subscribed to the CSI frame channel, and the callback which we will call is the self.update CSI frame. We can take a look at it. So we can take a look at it over here. sorry about that. It looks like the simple screen recorder overrides some of the VS Code shortcuts. So for example, this is the callback for the CSI frame, and all that we're doing is we're saving the last frame as part of the class. So this is self.current CSI frame just holds the last frame, and whenever we need to use that for something, we can just access it directly from here. The same is done for the Z frame, except the Z frame has a slightly more complicated workflow than the CSI streamer. So this is how we're getting data transferred from the CSI streamer to the actual web page handler, and then after that we can also take a look at how web pages are rendered. So the thing which I'd like to show you is the index. So this is actually the page which is rendered whenever someone accesses the web server's URL. This is actually the first page which is rendered, and the way we are doing that is by using a templating engine. So the advantage of using a templating engine over a regular let's say a regular like just plain HTML is that we can actually modify the HTML in real time. That's the benefit of using a templating engine. So using the Jinja 2 templating engine over here, and each page basically gets its own template, and the template is first read from a file, and then we apply whatever changes we need to do to that file. So if we need to change the HTML or add some text or something, we can do that with a call to .render. So that will actually modify the HTML just before the page is served, and after that it just returns a string which is just the HTML of that page basically. So this is a very simple workflow, and it makes it easy to create dynamic web pages. So for example, the one for recording handler is actually index, so we're just getting the base HTML, and then we're rendering the whatever messages we need to do. Alright, so this is recording handler. It's a very quick overview of the things which it does. It is actually also used for serving the camera capture page. So this page is actually used for two things. It's used for both the camera, the recording page, as well as the individual frame capture. So that is both done through this, and you can see the calibration is done in this method over here. One second. Yes, my bad. The calibration web page is actually loaded using this line of code over here. So what it does is it just sets the resolution of the camera, and after that it will load the template for the calibration page, and the page which is actually dynamically generated will depend if the Z camera is enabled, and also if object detection is enabled, because that causes a few differences in the UI. So that is for the recording handler. The other handlers are very similar in their workflow, in which you have to define which endpoints you want to expose, as well as which pages are meant for actual rendering and which ones are used for actually doing some function, for example. So now I'd like to show the Z process and the Z streamer. So Z process runs in a separate process, and it talks to the Z streamer, which runs in a separate thread. So this might be a little confusing, but I'll try to make it simple. So we have the web server process, and the web server process launches the Z streamer. So the Z streamer actually belongs to the main process. It's just a separate thread which runs on that process. The Z process is a different process altogether, and this is used for configuring the Z camera as well as getting frames from the Z camera. So let's just take a look at what happens over here. So until the Z streamer and the Z process communicate with each other using a queue. So we have two queues actually. One is a command queue where we send commands from the Z streamer thread to the Z process, So the commands which can be set are rec, which stands for record, and stop, which stands for stopping the recording. So this is done using a multiprocessing queue. That is one queue which we use. The other queue which we use is over here, the image queue, and the image queue is used for displaying the last frame which is captured by the Z camera. So that is what the queues are used for over here. And apart from that, we also use multiprocessing events, and the events are used for telling the Z process when to stop executing. So for example, when the Z streamer sets this terminate event to true, then the Z process has to stop executing and then it will close. So we have to close the queues, and we also have to disable whatever recordings are in progress. Apart from that, the constructor, the run function basically takes all the parameters you want along with the command queue and the image queue. So these are basically references which are initialized in the Z streamer. So the reason why we need a separate thread only for getting images from that process is because this needs to be running in the background continuously, and we need to continuously get data from the server. So similarly, we have the barcode handler. Barcode handler is similar to the recording handler in the way it works, which is that it will serve all requests which come to /barcode. The thing which is of note in this is that it uses a WebSocket, and the WebSocket is used for live server to client communication. So in this case, we're using the WebSocket for transmitting the data of any detected barcodes. So the way we're doing that is rather simple. Maybe you can say it's a hack of sorts, in which we generate the HTML over here. So whenever we have detected a barcode, then we will take this table and we will populate it with whatever barcodes are detected. So again, this is actually getting frames from the CSI frame topic. So as I said, CherryPy uses this publisher and subscriber model. So we're publishing to CSI frame, and the barcode is just getting the frame from using that. And the callback in this case is self.update frame, and in that what we do is we just crop the frame to our liking, because in this case the barcode frame is kind of cropped. So we crop it to our liking, and then we actually can put this through the barcode detector. So over here is where we're putting it through the barcode detector, and once we have done that, we will get an image of the detected barcodes, which we can then display on the screen. So this is where that happens. This is where you are resizing and also displaying the barcode. So this same piece of code is actually used in recording handler as well, getFrame. And what's going on over here is that we're byte encoding an image, a JPEG image, into basically a stream of bytes, and then we're just sending the stream of bytes to the client, and from there the client decodes it and gets a JPEG image. And this is done in an infinite loop, so it gives a simulation of a video, and that is how we get the live video streaming working. It's not very bandwidth efficient, but it's very compatible, as in it will work with all devices. Because over here what we're essentially doing is MJPEG video encoding, you can think of it as. So this is how the barcode works. I will be going through this in a moment, what these functions are for. We also have detection process, so this needs to be read with detection handler.py. So both of these work together actually. The detection process is just a separate process which runs on the Jetson, which only runs the neural network in an infinite loop basically. And what it's doing is it's doing two things. One, it can do distance calibration. So this is needed for getting a good estimate of how far away something is from the camera. We need to first calibrate the distance. So it uses a neural network for that. And the other mode which it runs in is actually doing the live object detection. So this detection process does both of those, and again, very similar to how we were doing for the Z process, we use queues for the inter-process communication. So we have a receive queue which gets an image. So we're actually getting the image using a receive queue, and then once we have taken that image, put it through the network, we get a list of detections over here. So all these are detections. We put that in a dictionary, and then we send the dictionary in a separate queue which is used for sending. So that is actually done in detection handler again. So in detection handler, we have actually created another thread, and that thread is basically just communicating with the detection process. So again, it's a parallel to how we were doing it for the Z streamer and the Z process. We need a separate thread only for talking to that process, so we don't steal any cycles which can be used for serving web requests. Yes, so over here is how we are getting the detections. Sorry, my bad. This is actually not using a separate thread. We are just doing it in the main thread itself. So the reason for that was because the latency of the neural network is quite low, so it doesn't end up blocking the main thread for too long. So in update detections, we get a new frame, as I mentioned earlier. It subscribes to the same CSI frame channel. So we can see that here, CSI frame, and the callback is update detections. So in update detections, it's basically we resize the image, put it in the send queue, and then wait for the neural network to return a result. Once it's returned a result, we can put that. We get those detections, then we can read that detections dictionary, and then build a table of all the objects which are detected and how far away they are from the camera. And once that's done, we just send it using a WebSocket to the client. Right. So both of these again are used just for displaying the video. So the detection stream is actually the bounding boxes overlaid on the camera stream, and the bird eye stream is it's basically like a bird eye view of all the objects detected from the camera. Right, so that concludes the handlers, how all of those are put together. The last thing which I'd like to cover is how the server and client communicate. So that is actually done using JavaScript and XML HTTP request. So let's go through some of those. I'll just be giving one simple example of how that's done. So for example, we have calibration. So again, this is because we're using a templating engine. All of these actually are built upon base.html. So base.html has some code, some HTML code, which is shared by all the pages. So calibration.html is just a fragment of that, and the way we're doing it, for example, we have a calibrate distance button, right? So how is that sent to the server? So we have a method execute action. So in execute action, we will take a URL. So in this case, the endpoint is let's see, the endpoint is calibrate distance, right? So in calibrate distance, calibrate distance is the argument over here, and that is what we're going to put in our XML HTTP request. So we send it using post, and we take that URL, and then we send it to the server using this. And then if you take a look at the calibration, so it's in recording handler, we have a method called calibrate distance. So it has a cherry pie expose annotation. That means that the server is exposing this endpoint, and that is basically what's going on over here. It's taking calibrate distance, and what it's doing is it's finding the list of images which are used for calibration, and then sending that to the neural network, and that is sent to the neural network using the cherry pie publish and subscribe model. And once that's done, we get a calibration result which we can then return to the server. So that is one small example of how we're doing the client and server communication. The other way we're doing it is via WebSocket. So the WebSocket example can be seen over here. So the WebSocket is used, for example, in the detection, right? So it's used for object detection because we want to get the live data of objects which are detected without refreshing the page. So first we need to specify the WebSocket URL, and once that is done, we create a new WebSocket object. And after that, once the WebSocket is open, whenever we receive a message, we then can modify the HTML to reflect that the results. Right, so that's how the WebSocket is done. It's done in a very similar fashion for the barcodes, because the barcodes are also updated in real time. So that is this part of the code that covers the handlers, the process, the streaming, and the multi-threading. And as you can tell, there are actually three processes which run in the background. You have the Z process, the detection process, and the web server process itself. So these are the three processes which are running in the background. And then we also have a couple of scripts here which are used for the headless startup. So basically these are started on an NVIDIA Jetson, and to have them start at boot, we have a couple of scripts. So we have two scripts here. Actually, one is the full, which enables all the features including object detection and the barcode detection, and the other one is only for recording. And the reason why they're different is because we can free up some computational load by disabling the detectors, and that gives a better performance in recording. So over here what we're doing is we sleep for 20 seconds to wait for the Jetson to connect to Wi-Fi or whatever, and we also have a separate 120-second timeout in the code itself. So once the Jetson is connected to Wi-Fi, then what we do is we will specify a log file. So all the STD out of the web server is actually logged over here, and then we run the web server using screen. And the advantage of that is that it can run in the background, and in case we need to extract any diagnostic information, we can just connect to this screen at any time. So yeah, that's these two files. Then finally we have settings.py. Settings.py contains all the settings basically. So the entire web server is configurable from here, and you can change these settings depending on your use case. So that is a summary of the features of the web server, and thank you for watching.